The next thing we're going to do is learn how to translate an equation from standard form into vertex form. So there's actually two ways we can do this. One of the ways is to do a process called completing the square. The reason why we call it completing the square is because we're trying to get our equation into vertex form. And if you remember, vertex form has what's called a perfect square embedded in the formula. It has this x minus h quantity squared. So we're trying to make that happen in order to get our equation into vertex form. So it's helpful to understand the properties of a perfect square. So what I have here are 12 different perfect squares that we're going to basically FOIL out and look for a pattern. Once we find that pattern, we're going to use it to basically create or complete perfect squares. So what I'm going to do here is just FOIL each one of these out. When you're FOILing out a perfect square, you're basically just multiplying that binomial to itself. So when we FOIL, notice that the first term always ends up squaring because we're multiplying it to itself. Also notice that when I do the outside terms and the inside terms from FOIL, right, first, outside, inside, last, the outside terms and the inside terms end up being the same product because I'm basically multiplying the first to the second, x times 1, and then again, but this time it's when I do the inside terms. I end up multiplying the second to the first. So you basically end up multiplying the first term from the binomial to the second term in the binomial twice. And then when I multiply the last terms, it's kind of like I'm squaring that second term in the binomial because I'm doing 1 times 1, which is 1. So this ends up equaling x squared plus 2x plus 1. Let's do another one. So if I FOIL out x plus 2 squared or multiply it to itself, I get x times x, which is x squared, right? I squared the first term. Then I get x times 2, and then again x times 2, right? I end up multiplying the first term to the second term twice, and those terms end up adding. And then the last term is when I square the second term in the binomial. 2 times 2 is basically 2 squared. So I end up getting x squared plus 4x plus 4. Let me show you one more. So I get, when I do x plus 3 squared, I get x times x, which is x squared, x times 3 once, and then again x times 3 twice, and then 3 squared, or 3 times 3. So I end up with x squared plus 6x plus 9. So when I did x plus 1 squared, I had a 2 in the middle. When I did x plus 2 squared, I had a 4 in the middle. And when I did x plus 3 squared, I had a 6 in the middle. So I'm hoping you're seeing a pattern. But to really drive the point home, I'm going to have you FOIL out the rest of these. I'm going to have you pause your video, FOIL out the rest of these, see if you can even use the pattern as a shortcut, and then we will summarize the results. Okay, so here are the remaining trinomials. So take a moment to check your answers. Make sure that you got the same thing when you FOILed out your binomials. While you're checking your answers, let's see if we can begin to notice a kind of pattern, or what happens when we multiply a perfect square. So first thing I want you to notice is that the C value, or the third term in the trinomial, is a perfect square. So notice every one of those numbers is a perfect square. But not just any perfect square, it's the perfect square of whatever that second number was in the binomial, right? 1 squared was 1, 2 squared was 4, 3 squared was 9, 4 squared was 16, etc. And it continues that way, and it will continue that way for all these binomials. So we know that if I want to create a binomial that's a perfect square, I know that I need to make sure that that last term is a perfect square. Now, how does it relate to the term in the middle is another thing we need to pay attention to. So notice that this third term was the perfect square of the second number in our binomial, and then the middle term was 2 times that second term in the binomial, right? So in a sense, I need to take half of the middle term, square it, that'll give me the third term. Let's look at it again with this x plus 8 squared. 64 was 8 squared. 16 is 2 times 8. So if I wanted to go from 16 to 64, I'd have to take half of it to get 8, and then square that to get 64. Let's look at this one over here, x plus 12 squared. The third term, when I FOILed it out, was the perfect square of 12. The middle term was 2 times 12. So the middle term is always double whatever this number is, and then the third term is the perfect square of that number. Now remember, we're going to have to come up with what this number is and what this number is. So we need to come up with a formula. We need to sort of generalize this to come up with a formula to help us create these perfect squares. Now remember, we are going to be starting with standard form, right? We're going from standard form into vertex form. So we're going to have something that looks like this, and we're going to want to convert it into something that looks like this. So I have to create this standard form thing, something x squared plus something x plus something, to create a perfect square. Now, for this video, we're only going to work with ones that are considered to be an easy standard form, because we have another process for when it's a little bit more complicated. So what's easy standard form? Easy standard form is when a is equal to 1, right? It's easier to factor standard form equations like that. It's also a lot easier to complete the square. And when b is even, we're going to work with ones like that. So it's going to be something like this, x squared plus bx plus c. And what our job is going to be to try to create the perfect c that would make a perfect square trinomial. So probably what we'll have to do is get rid of the c that's already there and come up with our own. So when we look at the pattern here, we notice that the c that makes this a perfect square trinomial is the square of half the middle term. So what we're going to want to do is take our middle term from our trinomial, b. We're going to want to take half of it, right? Because look at each of these factors. The number that was the second number in my binomial was always half the middle term in the trinomial. So when I start with the trinomial, I take that middle term and I want to cut it in half. I want to divide it by 2. And then I want to take the perfect square of that. I want to square that number. If I can do that, then I would create something with double this number as my middle term and the perfect square of that number as my third term. And then what's that number? That number would be the b over 2, half my middle term. And so that's what we want to try to create in order to get something that looks like this. So let's repeat those steps and try it with a few examples. So once again, to translate from, I'm going to put easy standard form, where a is 1. To translate from easy standard form into vertex form by completing the square, we are going to subtract the c value from both sides. Okay, so remember, we're starting with something that looks like this, but the c value that's there is maybe not the number we need for a perfect square. So we're going to get rid of it. We're going to just kind of temporarily move it to another side. We are then going to complete the square. What does it mean to complete the square? It means to figure out what numbers should go there so that I end up with a perfect square trinomial. So to do that, we divide our b value by 2. We take that middle term, we divide it by 2, and then we square the result. So we take that divided by 2 number and square it, and then we add that number, add that newly found square to both sides. Because what that will do is create a perfect square trinomial on the side we need. Then we're going to go from that perfect square trinomial and factor it into a perfect square. So that's when we say, okay, x squared plus bx plus half the middle term squared, that's going to factor into a perfect square of x plus b over 2 squared. How do we know? Because we observed the pattern over and over again when we multiplied out perfect squares. We saw that the middle term will always be 2 times whatever this number is. So then we'll make that number half the middle term. And the third term was always the perfect square of whatever that number is. So we're using that observation backwards in a sense to create this perfect square trinomial to form this perfect square of a binomial. Now, because we had moved c to the other side and added b over 2 squared to both sides, we end up with this k value that we need to add back to the other side. Let me show you what I mean in example 3. Okay, so in example 3, here is my standard form, right? This is in standard form right now because it's x squared plus bx plus c. It's an easy standard form because a is 1. So what I want to do is get rid of that c value because 5 is not a perfect square. 5 is not going to help me factor this into a perfect square. So I'm going to kind of just move it out of the way for now. It's still over here with y. So I just kind of think of the left as y minus 5. But now what I've done is I've opened up a spot for the perfect number that could complete this square. So what I'm going to do to complete that square is I'm going to take my middle term of 6 and divide it by 2, because I know that once I do factor this into a perfect square, whatever I get as my second number in the binomial is going to have to be half this middle term. I also know that I want to square that number because this third term has to be the perfect square of whatever that second number is in my factor. So if I take half of 6, which is 3, and square it to get 9, I am basically creating that scenario. I'm like forcing it to happen. But I can't just add 9 to one side because this is an equation. So to keep it equal, I have to add 9 to the other side. So this will actually be y plus 4 on the left. See, that number changed when I added the 9 to both sides. Okay, so now I have x squared plus 6x plus 9 on the right-hand side. Now you might remember, let me just scroll back. We saw that one earlier, right? That one was right here. X squared plus 6x plus 9 is what you get when you multiply out x plus 3 squared, right? That's why I had to take half of 6. I needed to get 3 and square it. So when I factor x squared plus 6x plus 9, it factors into x plus 3 twice. When I factor this, remember I factors into x plus half of b squared. Half of b was 3. So I get x plus 3 quantity squared. Remember, that's also because when you are factoring a trinomial, you're looking for two numbers that multiply to 9 and then add to 6. 3 is that perfect number because 3 times 3 is 9 and 3 plus 3 is 6. So because it's the same number twice, it's the same binomial twice, x plus 3 quantity squared. Okay, so now I've got my perfect square, which is what I wanted all along. But I also have this number 4 on the other side that I need to subtract back. This needs to be over here in order to have this in perfect vertex form. So then I get y is equal to the quantity x plus 3 squared minus 4. Now I can see my vertex. My vertex is 3, negative 4, because I have gotten it into the vertex form, which is this, a times x minus h squared plus k. A, of course, is just 1. So that's the process for going from standard form into vertex form. I'd like you guys to try that with number 4. Okay, so looking at our steps here, we begin by subtracting the c value to both sides to make way for a new c value. So on the left side, I end up with f of x minus 8. On the right side, I end up with x squared minus 10x plus blank. Now, to fill in that blank, we follow this process of taking the b value, which in this case included a negative, and dividing it by 2. So that gives me negative 5. When I square that, I still get positive 25, which I then need to add to both sides, leaving me with a positive 17 on the left instead of a minus 8. Then on the right, I now have a perfect square trinomial because I have a 3 terms where the middle term is 2 times negative 5, and the third term is negative 5 squared. So it can be factored into x minus 5 squared. Don't forget to make it minus 5 instead of plus 5. But then on the left side, I still had the plus 17, so I needed to subtract it to the right to get it completely in vertex form. And then I can see that my vertex is 5, negative 17. Because remember, your vertex, the h coordinate in the vertex is always the opposite sign.